Thank you for joining the January 8th, 2019 VOLTHA call. Today our main topic is going to be on discussion related to the tech profiles in Flow Decomposer and Vol 736 and 1367. And do keep in mind we record these, so need to keep that as a thought when you're doing any presentations and during discussion as well. We do post these to YouTube. If we do have some additional time, we can briefly touch on one of the email threads from today on Golang package versioning for VOLTHA 2.0. And then also we'll talk about the ideas for the follow-up discussion on 1022. So I'll save that for the end. And then with that, Sean, I think I will hand the presentation rights over to you.
Okay, thanks, Julie. Let me see if I can show a screen here. I had some terrible problems with this last time.
Did you have the file in the did you send out the file? If you'd have, then maybe someone else can present.
I did send out the
I think you sent on VOLTHA discuss. Do you need me to take presentation rights back?
Yeah, can you just do that for a second? Thanks.
Okay. Oops, hold on.
Yeah, all right. This is not good.
And see if I can get this open here.
Maybe enlarge it a little bit.
Yeah, I'm trying to see how to do, oops. It went away. Where did it go?
Julie, you're forgiven. You're sick.
Can you tell? Okay. All right, I can't find it again. Where did it go? Here we go. There should be somewhere on here.
The bottom, yeah.
Ah, here we go. Thank you, Sean.
Okay, thanks, Julie. Yeah.
Just cue me when you need me to change pages.
Okay, so Garish and Craig were actually working on Vol 736, which was basically integrating the technology profile work into the system. And it kind of came upon a bit of an issue that we had some email discussions around. I just wanted to kind of summarize, what the issue is and talk about some potential solutions. Could you just go to the next page, Julie? Yeah. So this is just essentially a picture of basically a single OLT with a single ONU, and we're going to be talking about basically a single flow of basically this high-speed internet access service. And basically on the uni part of the ONU, it's using priority tagged frames, and then the ONU is going to add a tag, VLAN tag 2, onto the frame for transport on the PON. Well, actually, it's going to change priority tag to be VLAN tag 2. And then the OLT is going to be adding an outer S tag. So basically, as the frame leaves the OLT going to the aggregation switch, the frame has S tag 12, C tag 2 in this case. And the reverse process occurs. The OLT removes the S tag in the downstream, so that again on the PON, the frame has a VLAN tag 2, and then the ONU will change that to be VLAN 0 priority tag frame and sent back to the RG. So we go to the next slide. So this is just a problem statement. So basically, when ONOS configures a upstream or a downstream flow, the flow is basically split into two parts, right? There's a table 1 part and a table 0 and a table 1 part. So table 0 has ingress, egress port, match action rules, and then transition to table 1. And table 1 is doing the second part of the translation of the frame. Again, defines what the ingress, egress ports are, the match action rules, and then the final transition is to a table, flow table, which is actually the tech profile table reference. Table 1 also has a meter reference that can be used downstream and upstream to define the in the upstream direction the DBA bandwidth profile, and in the downstream a similar downstream bandwidth profile for the flow. So the flow decomposer in the vCore sends each table data to either the ONU or the OLT adapter. So upstream, the ONU gets table 0. There's no tech profile information or meter reference in that table. The OLT gets table 1 that has the tech profile reference. Downstream, the OLT gets table 0, and the ONU gets table 1. So they're, upstream and downstream reversed as to who gets the tech profile information. As a side, another issue is kind of order dependency as well. So basically, currently OLT is the one that creates the tech profile instance, and the allocates the TC layer resources. The ONU needs to use this tech profile instance, so it'd be better if it was already there when the ONU needs it. The ONU also needs the upstream flow data, ideally first, in order to create the extended VLAN ME. And in the ONU, basically the default mode of operation for our use cases is the downstream frame processing is the inverse of the upstream. So in theory, you don't really need to explicitly define what the actions in the downstream on the ONU, because it's just going to be the inverse of the upstream as far as tagging is concerned. And okay, I guess we can go to the next. Any questions on that one? Or so I mean, and really, so the issue is that the tech profile information isn't available all the time. So because the table is split into two pieces, and only one piece of the table has the tech profile information. So and basically, the ONU adapter needs that, and the OLT adapter needs that to create, because the tech profile information has information about the queues and the gem ports and the scheduling policies, PON-related things. OpenFlow doesn't have any of that. It just has the match action rules for the frame. So this slide is showing basically the provisioning of the high-speed internet access upstream flow table 0 data. So this is the information that comes down in OpenFlow, basically. So the port 30736 is a uniport. CTAG is 2, which is transported as 4098, which is 4096 plus 2. I guess there's some convention there that was used. So there's the ports defined. So the ingress port is defined. The VLAN to operate on is defined 0, and basically we're going to set that VLAN field to be 2, 4098, which translates to 2, and then we're going to output that on the PON port. So the high-speed internet access flow upstream table 0 comes down from ONOS to the OpenFlow agent. It's past the vCore flow decomposer. This is a 2.0 statement, and basically that table information is for the ONU, right? So that gets sent to the ONU adapter. So again, in this table, there's only tag actions. There's no technology profile. So the ONU adapter can't really create anything for OMC IMEs at this point because it doesn't know what resources to use, what gem ports are being used, ALEC ID, etc. If you go to the next page. So this is kind of just showing how the ONU adapter would kind of use the provisioning data to set up this high-speed internet access flow, right? So this right-hand part of the screen is essentially all configured via the technology profile, and the left-hand part, where the extended VLAN tagging operation, this part's all done with the OpenFlow information, the tag action rules. So without this, the right-hand side of the screen here with the tech profile information, we can't really set this up. Okay, I guess we can go to the next screen. This one is the flow table 1 of the upstream flow. This one's going to be passed to the OLT. So basically, in this case, we define the input port as the uni. The VLAN is 2. We're going to push. We're going to push another tag, the S tag on top of that, which is VLAN 4108, which is 12. So ONOS again. We've done the table 0 flow. Now we add the table 1 flow. It goes down to the vCore, gets sent to the OLT adapter. In this case, it does have the technology profile reference and the meter reference. So the OLT adapter can actually go and set, the DBA mechanism and the queues, etc. It can go set all that up, and it can go and create the tech profile instance that the ONU adapter can use. So we go down to the next slide. Okay, and this one is talking about the downstream flow table 0 data. So in the downstream flow, the order is kind of reversed. So table 0 goes to the OLT adapter. Again, in this case, there's no technology profile instance. But depending on the order of which things happen, if it gets the upstream first, then it has it in that case. And then if we go to the next picture, and this is downstream table 1. This table 1 now goes to the ONU adapter, and the ONU adapter then gets the tech profile reference. Okay, can we go to the next one? And this is just a statement of order dependency. Normally the upstream flow is configured on the ONU, and the way the extended VLAN tagging works is that the downstream operations are selected to be opposite of the upstream. So in this case, I really only need to configure the extended VLAN tagging ME for upstream, and the downstream is then becomes the reverse. And again, we need the tech profile information so we can set up the rest of the MEs for the PBIT mapper and the gem port mapping, etc. So we just go down to the next slide. So the problem is basically, depending on which piece of the flow gets down to the ONU or the OLT, it either does or doesn't have the technology profile information with it. So if it doesn't, then we kind of stuck in that we can't really configure anything, and we end up in a situation where we have to be either stateful, have to wait for all the pieces to arrive, or somehow we have to stick the tech profile information into some other fields in the flow, so that once one flow is received, all the information is available for the ONU. And some of the potential solutions to this problem that we discussed is, so one is, so one was the flow decomposer basically doesn't forward the table 0 flow until table 1 flow is available. The flow decomposer can add the tech profile instance information to the table 0 flow that gets passed down to the ONU and to the OLT. So kind of overriding the reference to, you know, the table 1 reference at the end of the table 0 flow. Another option is the OLT generates a single flow message containing both table 0 and table 1 operations, right? So we need to figure out, you know, how this would work. You know, obviously there'd have to be quite a few changes to the ONOS apps and to the you know, flow decomposer and the adapter and ONU. So I mean, some of the issues with doing option 2 would be you need a convention as to what, you know, what the OLT does and what the ONU does, and we already have an idea of what that is, but you'd have to somehow enforce it. This might be a more scalable solution, because now we just have a single message that defines the upstream flow and a single message that defines the downstream flow, and you deliver all information that the OLT adapter and the ONU adapter needs. Another option is table 0 encodes the technology profile reference as some kind of metadata. This may get messy if we introduce MPLS or something at some point. And the ONU, last option here is, you know, ONU and OLT adapters wait for a technology profile reference and meter reference to be available before configuring the flow. So basically, stateful operation in the adapters. Yeah, and I guess there's been quite an effort to kind of avoid that. So, and if you go to the next,
Sean.
Yeah.
Can I ask you one question, please?
Sure.
Why do you think option 3 would get messy with something like MPLS?
Well, if you need to pass, ooh, I'm getting a lot of echo here. So if we need to pass metadata, you know, from one block to another, you know, we may be kind of overriding something. We may need some metadata field that is already being used. Just thinking that it may, you know, if we're kind of sticking these fields as metadata, it may become, you know, unwieldy.
Because OpenFlow has some, I believe it's experimenter field, which could be used to transfer some proprietary information.
Yeah. So I mean, originally when we were kind of talking about the technology profiles, we had discussed use of the experimental fields, and that was kind of, I guess, frowned on initially, just because the idea was we just want to use the existing standard.
Okay, get it. Thanks.
Okay, so if you just look at what a couple of these solutions might look like, the next slide, I think. Yeah, so this is just an example of solution 1 that was proposed. So the flow decomposer basically doesn't forward the table 0 flow until table 1 is available. So basically, you know, ONOS provisions table 0 flow, gets down to the flow decomposer, and the flow decomposer looks at the table 0 flow and see that it references table 1. Then if table 1 isn't available, it doesn't send it. And then once table 1 comes down for that flow, it looks it up, sends it off to the, in this case, the OLT adapter, and then checks to see if table 1 was referenced by table 0. If it was, then it overrides the table 1 reference in the message it sends to the, in this case, the ONU adapter with the technology profile reference. If we go to the next one. So here the OLT generates a single flow message containing both table 0 and table 1 operations. So this is a single message for the upstream flow. Goes down to the vCore flow decomposer, and it sends the upstream flow to both the OLT adapter and the ONU adapter. This is just showing the OLT adapter creating the technology profile instance if it doesn't exist, and the ONU is using that once it gets the flow data. Same for the downstream data. In this case, it's a single message, and the flow decomposer again forwards the downstream flow data to the OLT adapter and ONU adapter, and basically they both get to use the TP instance in that case, because all the information is available in the message. So this is kind of the discussions that have been going back and forth around technology profile implementation. So basically, we're kind of missing the technology profile instance in kind of half the messages, and so the ONU and the OLT adapter can't really do anything with the flow data that comes down until they have the technology profile instance, because that's common between both OLT and ONU, and that ties them together, and it defines the PON part of the flow. So these are some thoughts around what possible solutions to this issue. And so I think is Saurav on the call?
Yes, I'm here. Sorry. While on mute. Yeah.
Yeah. Hey, so given the issue kind of we're talking about, hopefully this kind of explained a little bit about what the issue is that we're seeing. I don't know if you have any thoughts on an approach, either having a single combined thing, or modifying the existing operation with table 0 and table 1. Again, a bit of echo.
Hey, Chip, your line has echo.
So yeah, let's see. So even if you pass both upstream and downstream, no, wait, you pass. You did something that both table 0 and table 1 flows were sent to both ONU and OLT adapters, right? Earlier, only one of them was going to one of, like.
Well, it's split up. So basically, the architecture right now is that the the ONOS apps separates the domain of interest for the OLT and the ONU, right? So table 0 and table 1, depending on the direction, upstream or downstream, whether it applies to the ONT or the OLU flips, right? With one or the other.
Yeah, that's true. Yeah. Although it wasn't really done, it wasn't really done with an OLT and ONU separation in mind. It was more about open flow semantics.
Yeah. Okay.
But I'll come back to that in a second.
Sure.
But if you continue using 2 flows for any one direction, right? Like we used today, table 0 and table 1. And if you pass both of these to both adapters, you still have a problem, right? Because one could arrive earlier than the other and you have to wait and all that. Is that what it is?
Yeah, so that's one thing. So we become a little staples. So if you go back one page here, Julie. So here, this is showing, table 0 coming down, and basically this is, if table 1 isn't available, then it just waits. It doesn't send table 0. And once table 1 comes, then it can send both table 1 and table 0 to destination. All the other option here is the adapters have state, and they just wait until they have both pieces, right?
Okay.
Sean,
I mean,
sorry, just a quick question. Sean, is there a relationship between table 0 and table 1? For example, suppose we go with the option 1. Is there some ID, something that when the table 1 is received, that will knows that it needs to refer to the previous flows in table 0? Is there something that matches them?
Yeah, isn't there there's some kind of flow ID? Is it the cookie or?
no, the table ID is part of the flow.
Yeah, it is, but it's two separate messages, right? So the question is, I get table 0, then I get table 1. How do I know table 1 is for the is related to table 0 for this flow?
No, you don't. No, so it's not done that way. Okay, so the reason why multiple. So let me now come back to that open flow semantics question, right? Why are they separate flows in separate tables, right? And why aren't they related to each other? Back in the day, excuse me, back in the day, in the OpenFlow 1.0 days, right, when there used to be only a single table, there was this concept of, well, yeah, but a single table is nice and simple and powerful, but there is also the possibility that you could have an explosion of flow rules, because you have to do this, I forget the term that we used to use. But the point was that if you use two tables, you can match on, say, one field in one table and then another field in another table, right? So you could say have 10 ways to match on the first field, and depending on that, there's maybe 100 ways to match on the second field, right? So total number of flow rules that you use is 10 plus 100, it's 110, right? But if you only used a single table and all possible combinations of those fields are possible, then you end up with 10 times 100, so 1,000 flow rules, as opposed to 110, right? So so the subsequent versions of OpenFlow basically wanted to get past this problem of exploding number of flow rules, because you have to specify all kinds of combinations of matches by matching on different things on different tables. So if you now take the example of the pawn in VOLTHA case, right? The first table matches on the outer VLAN, and then you pop it off, and that exposes the inner VLAN, and so you match on the inner VLAN on the next table, right?
Yeah.
So the same but in the specific case of VOLTHA, it actually doesn't matter. This kind of cross multiplication explosion won't necessarily happen in VOLTHA's case. So I believe in VOLTHA's case, we could find a way to just use one that matches on both VLANs and pops them off both and sends them out of a port.
Right,
but the historical reason for using two tables was not because one was meant for the OLT and one was meant for the ONU. It was just open flow semantics of optimized flow rule matching.
Yeah, so it's yeah, I mean, there isn't a one-to-one map between table 0 and the OLT or ONU. I mean, it flips, right, depending on the direction of the flow. Exactly. So but there are two domains of interest around processing of a packet, right? So there's what the OLT does, and there's what the ONU does. Both in the upstream and the downstream direction. It seems like that those separation of interests are somehow taking advantage of table 0 and table 1, right? But I mean, but I guess it doesn't have to, is what you're saying. It doesn't. It wasn't really
it doesn't
designed like that.
Yeah, we might have a little bit of an issue with just the wire protocol, because there is no concept, at least in the OpenFlow version that we use, of matching on an outer VLAN and an inner VLAN. But I've seen people do have ways to get around it. If that is, you want it to become one flow. If the solution you go with is making it one flow, then you have to match on two VLANs, right? VLAN outer and inner. And there is no concept of an outer or inner match. It's always out in OpenFlow.
Yeah,
so, yeah.
I don't think we don't want to break OpenFlow, right? But we do have this problem where, you know, both OLT and ONU need to have the tech profile reference.
Yeah, that's right. So I think yours option 2 was I feel it's my preferred way. Option 1 could work. I generally don't like things like, oh, I have to wait for this to happen before I take action. But it could work too. I can explore option 2 to see how people are doing multiple VLAN matching in the same flow message in other instances. That might instruct us, I mean, without breaking OpenFlow rules.
Yeah. And then we have to be aware that, you know, we want the OLT to do certain operations, right? So in the standards and everything, that, you know, basically the OLT is the one that adds and removes the outer tag, and the ONU is the one that handles the inner tag.
Yeah.
So there's no way to enforce that if it becomes a single flow, right? There have to be some accepted ways of doing it, right?
Well, so let's see. For popping off VLANs, so that's why it's always assumed that you're popping off the outermost VLAN. So, so if you put two pop actions, the first pop action applies to the outer VLAN, and then the second pop action applies to the inner VLAN.
Yeah.
So when it reaches VOLTHA's flow decomposer, the flow decomposer basically has to figure out that, okay, so the first pop action should be done in the OLT, and so the flow that it decomposes should match on the outer VLAN and pop off the outer VLAN. And when it sends it to the ONU, is the other way around. Well, the single flow is actually going to be sent to both OLT and ONU. Is that right?
Yeah. So that was that's what I put down in the flow sequence diagram, that maybe the flow decomposer wouldn't really need to know, right? It could just pass those off to the OLT and ONU.
So it really doesn't decompose anything then. Right.
It wouldn't. It'd be forwarding, I guess, or routing it, or however you want to.
So is there a need for a flow decomposer at that point then?
Yeah, I don't. Well, it would have to be distributed, I guess, in the OLT and the ONU. They'd have to somehow know what bits they have to do.
If you forward the flow from the core into the adapters and let the adapters decompose the flow, in 2.0 onwards, the adapters have no notion of logical devices. Will they have enough information to be able to decompose the flow without knowing anything about logical devices?
Yeah, no, but they know it's an OLT and it knows it's an ONU, and there's operation.
If we take a flow that's coming from ONUs transparently and we send it to an adapter, the flow from ONUs is for a logical device.
Yeah.
And when it goes to the ONU, to the adapters per se, it's for the physical device. So there should be some form of decomposition that happened that make it specific for the adapters and remove that logical references.
Okay, but then the, I guess we have the situation now where I guess the vCore needs to, the flow decomposer needs to understand the architecture of the OLT and the ONU, right? To do that decomposition.
Yeah. Ken,
Yeah.
even in 2.0, although the adapters do not have knowledge of the logical device, but the OLT does know about the ONUs. It's the one that assigns the port names and port numbers that are used in the logical device. So won't you agree that the OLT adapter has all the pieces, bits and pieces that go into the logical device, but yeah, it doesn't have that logical device that binds them together. So it, in theory, it could. I mean, it has all the pieces of information to take this to take the flow and do whatever it needs to, decompose or whatever, because it has all the information.
It has all the information as long as we preserve them when it goes into, for example, all the IDs of the ONUs of the UNIs are preserved as is, and the code doesn't even change it to its own unique one. But does it mean if we go that way, we'll have decomposition in all the adapters? And do we really want that?
Well, I don't know. We're exploring, I guess.
Yeah, I guess the OLT knows the system, right? It knows the ONUs that are attached to it.
And the IDs in the logical device, these are the OpenFlow port numbers, right?
Yeah, that's good.
And what you're saying, Ken, is that these OpenFlow port numbers in the logical device are not necessarily the IDs for the physical device?
Yeah, because in 2.0, we wanted really to separate really a logical device totally from the actual physical devices, so that there's no really like a direct mapping. But if we're going towards a way where we want to transport this and everything to the adapters, then we'll have to preserve whatever the adapters assign, whatever IDs those the adapters assign to those uniports and NI ports.
Okay. So port number assignment was not done by the adapters in the 1.x branch?
In 1.x, yes, but in 2.0, I wanted to remove that.
Ah, I see.
Yeah, Ken, I understand. So yeah, the mapping is still in 2.0 will be in the core between the OpenFlow IDs and the physical IDs, and this would be needed, for an adapter to understand the flow if the decomposition is happening in the adapter. But so, if this is available by the core as a mapping service, then yeah, it could be done by the adapters.
It's more like a translation then. It's not really decomposition.
Yeah.
Translating numbers from the logical device to the actual physical device numbers. But you're not really decomposing, because for one thing, if you take those two flows, the flows that go to table 0 and 1, make them one flow and send that one flow to both ONU and OLT adapters, there is no decomposition really. It's really a translation of IDs and then shoveling them down to the appropriate adapters.
Yeah, pretty much.
Yeah, okay. I understand what's going on. So, Sean, did you have anything else?
I think that was it. I just wanted to state what the issue is and then some potential solutions, right? So obviously this isn't the whole set of potential solutions, but it seems like a single flow message that has everything would solve the problem. But we could, like, the solution one would basically be, I could add on the technology profile information to the table 0 once I have it, right? But that would someone would have to basically know not to send table 0 on until it had table 1 information available. And that would have to be the flow decomposer, I guess.
In general,
I have a quick thought.
Yeah, go ahead.
Sorry. This seems obvious to me, but I'm probably overlooking something. Regarding idea number 2, why would we not want the flow decomposer to actually perform the function implied by its name and take the single message, decompose it into device-specific flows, and then send it to the OLT and the ONU so that they don't get more information than they need to know, and they are left to interpret that differently across different adapters? It just seems like actually decomposing a single message is the ideal function for the flow decomposer to handle that in the core, to decompose it on a per device basis. What am I missing there?
Actually, yeah, Philip, I think you're right. I was probably adding these two things together. But what you're saying is, okay, ONOS sends one flow. The flow decomposer in a breaks it down into 2, but then passes along the TP information to both OLT and ONU adapters.
Yeah, exactly. And the adapters wouldn't even really have to change. They would see essentially what they've seen before, except updates for technology profile and metering and all that.
Right. Would that work, Sean?
Oh yeah. I mean, that's essentially, I guess, combining 1 and 2 together, right?
Exactly. Yeah, combining.
Well, it combines 1 and 2, but it removes the statefulness of what in number 1 of waiting for that second flow, which is a huge headache.
That's right. Yeah.
Flows.
Yeah. No. That's right. Yeah. So I mean, that solves that problem.
Yeah,
but
I think that's something we could all be happy with, I think.
Yeah. It seems like we just need to make sure the syntax supports what we want to support.
That's an action item on me. I have this feeling that we have done this before, this inner VLAN, outer VLAN stuff. I'm going to have to go and explore it a little bit in ONOS, and if so, then I think we should be okay in just sending a single flow message.
Yeah, I think Craig actually suggested this. I think he'd seen a solution somewhere else, I guess. So I guess it must be possible, I guess.
Yeah, just let me look around, and if somebody else finds it also in the meantime, please let me know also.
Hi, this is Fahad from North Forge. Just to jump in, actually the ONOS application sends one instruction actually containing all the open flow instructions, but it's the OLT pipeline in ONOS core that actually splits it in 2. So what we need to do here is simply just move the functionality from the OLT pipeline down to the Decomposer in VOLTHA. So it should work because we already, I mean, in ONOS, the ONOS application, the OLT application, it already sends it as one set of instructions.
Okay, but that doesn't fix my problem that OpenFlow, the protocol itself, the wire protocol, does not have the ability to match on 2 VLANs.
Okay.
Right. And maybe that's why the driver splits it up into a table 0 and 1 flow. So if that is the case, I mean, the wire protocol is extensible, and we could create an extensible match where we do indeed match on both VLANs. I mean, so the standard match in OpenFlow would match on the outer VLAN, and then the extended match would match on the inner.
Yes, Saurav, in the current OLT pipeline, the pipeline is placing the inner tag in the upper 32 bits of the metadata field. So that's a possibility.
Yeah, I guess it kind of hides the second match in the.
Yeah. Okay. So that's also possible. Okay. Yeah, you know, just give me a little bit of time to think about it and explore. All the suggestions that you've made are all valid. So if that's what we decide to go ahead with, then yeah, I just need some time to explore. But if one flow is what you want with all the information coming from ONOS, the decomposer decomposes and translates and sends the relevant information to the OLT and ONU adapters so that they are both happy and nobody's waiting around for information to come from something else. I think that's pretty good.
Yeah, I think that as long as all the information is available so that they can take action without having to wait, basically, and have stateful information. Yeah.
Yeah, I mean, it's a little bit ugly if, you know, we put the outer VLAN match in the regular VLAN match, and then the inner VLAN match as metadata.
Yeah, that's what we're doing right now, though.
No, but that's really to hint. Okay, that's really to hint at. But if you look at the flow in ONOS, they make sense, right? There's an outer VLAN match. We pop it off. That exposes the inner VLAN. We match on that in the next table. We pop it off, right? Like from OpenFlow semantics, it makes sense.
Sure,
right?
yeah.
Now you have one flow, right, which is outer VLAN match, and then the inner VLAN is hidden in the metadata, and then for some reason you're popping off twice in the actions, but you know, it's not. It doesn't intuitively make sense, right? Why are you popping off two VLANs? You only matched on one, and then you hid the second VLAN in the metadata. You know, so.
Well, that's, I mean, at the OLT side, right, I need to match on both the outer and the inner, right? But I only want to pop the outer. That
is correct, yes.
And then the ONU is responsible for popping the inner one, or it becomes the outer one at the ONU, but yeah. Okay.
Yeah, so maybe the cleanest way to do it is to have this extensible match. It's more work than simply hiding it into metadata. But yeah, so just give me a little bit of time to explore, and I'll send something out on the mailing list and ask for opinions.
Okay, sounds good. Well, I guess so. Just to satisfy my curiosity, so it sounds like the OpenFlow message itself has all the table 0 and table 1 information in it for an upstream flow and a downstream flow. Then within VOLTHA, there's a separation into two parts. And those two parts are passed down to the flow decomposer independently, currently.
Yeah, I think so.
It sounded like that. I mean, but so when you could, as a first step, just remove that separation, right, and then pass the whole thing down to the flow decomposer. Then it can do what we said because it has all the information.
pass both flows down to the...
No, just instead of having it separated out into table 1 and table 0, if the message has both table 0 and table 1 in it, when it reaches the flow decomposer, then the flow decomposer can...
No, I think you're assuming that the OpenFlow message has both table flows.
Oh, yeah, so I thought someone said that was the case.
No, that's not true.
Okay, all right.
They are separate messages.
Okay.
Oh, okay. Oh, I know where you got confused. In ONOS, there are separate layers, right? There is the app layer, and then there is the actual driver that sends out the OpenFlow messages, right? And what the gentleman was talking about was that the app still sends one flow, but then it gets split out into two in the driver.
Oh, it sounded like that was in VOLTHA. But if it's in ONOS, okay. So could you just go to the next page, Julie? Yeah. So this is still true, right? So the ONOS has sends two messages, one for table 0, one for table.
Yes.
Okay. All right. Okay. Good. Okay. All right. Okay. So I guess we'll kind of just leave it with you then, Saurav, just to noodle that a little bit and see what the cleanest approach is.
Yeah.
That may entail a bit of work, but we'll have to see where that goes. Okay.
Okay. Thanks.
Okay. Should I go ahead and close up the presentation?
Yeah, unless there are more
last
questions.
look at anything before? Okay. Let me close that up, and then let me go back. We've got about 7 minutes left. Hopefully we'll have a couple minutes here. I do want to jump down since I did see we've got Jason and Bjorn and Amit on the call as well as others. So Bjorn, I'll kind of explain my thinking here. I had not been able to find a time slot that worked for all the time zones. So I thought maybe I'd try and get one that worked for most of the time zones for the developers and then have a follow-up recap on like one of the VOLTHA meetings. But we can shift and find something, but we're probably going to lose some folks no matter what time we pick. So for if we want to move it from today, I could move it out. Let's see, this is at 7 to 8. I could move it out later, up to maybe 3 hours later or so. I don't know if that works. I think that would probably work, Jason, on your side, unless you have another meeting lined up. And then Amit and others. Any thoughts on the time for the Vol 1022?
Julie, you're talking about 10 p.m. Pacific time, or what?
Yeah.
What are you?
Yeah, 10 p.m. Pacific. So 10
okay,
or
that's 7 a.m. in my time zone. So that would be good for me, of course.
Okay.
But I don't want to mess up everything. So
well, we might lose the North America folks, but I'm not sure. I don't see Craig on the bridge today. I was hoping he could chime in as well. So let me ask for the folks who are on the bridge today. Jason, since I know we need you on there since you're assigned for this one, can we move this meeting 2 hours later? Would that work for you? I'm trying to remember what time this is in Taiwan, how we had it set up.
Hello?
Yes?
Can you hear me?
Yes.
Yeah, I think so. So you can change the release time 2 hours later.
2 hours later. Okay. So actually 2 hours later. So Bjorn, I think so that it was 7 to 8. So that would be 9 to 10. That's still 6 your time, isn't it? So we need to leave it 3 hours to 10.
And 2 hours is fine for me as well.
Okay. And Amit, would that work for you on your time? I figure as long as we move it later, it's probably okay.
Yeah, Julie, that should be okay.
Okay. So let's go ahead and do that. I'll adjust it on the schedule. We'll do it 9 to 10 p.m. Pacific time tonight, and then we'll catch as many folks as we can, and then we'll see how that goes. Okay, so Bjorn, I wasn't trying to exclude you. I was just trying to figure out, I thought we might have to have 2 meetings regardless, but I didn't convey that in the email, so my apologies. Okay, so I'll shift that time. And then we've got 4 minutes. I know there's been some discussion on it already this morning on VOLTHA Discuss related to the Golang package versioning for VOLTHA 2.0. Do we want to discuss that for a few minutes here, or just continue the discussion on VOLTHA Discuss?
We probably just, there's already a couple of comments on VOLTHA Discuss, so perhaps we can solve it there by Thursday.
Okay, and then if we need to follow up on Thursday's call, we probably will have some time we can do that. Okay. All right, I think that's it. So I will let everyone go for today. On Thursday, we do have a plan for a discussion on multicast. And Amit, I think you were giving a presentation there. And then Sean's still working on something else, but we've got some schedule conflicts. So we'll see if anything else gets added in. And then I've tentatively put in for next Thursday some VOLTHA 2.1 planning. And so Sean and I have been working on some draft slides that I'll get the draft changes visible this week on the planning slide on the wiki. With that, I think we'll wrap up for today. Any other comments from folks before we drop the bridge? Okay, thanks everyone. And I will go ahead and stop the recording.